Hello, and welcome to the Open Systems Media eCast, tips for starting small while building your business case for IoT. I'm your moderator, Brandon Lewis, here with today's speakers, Jordan Reynolds and Michael Glessner of Calypso, and Rob Patterson of PTC. I'd like to start by more formally introducing our speakers, starting with Rob, who is VP of Product Marketing in the Technology Platform Group at PTC. Rob joined PTC ThingWorx through the acquisition of ColdLight and has a deep background in analytics and machine learning. Rob has successfully built highly disruptive and creative strategies at various technology companies around the world, and prior to his role, held senior marketing positions at Qlik, where he built customer marketing teams globally and worked to evangelize the QlikView platform with enterprise clients. During his tenure, QlikTech went from $38 million in revenue to well over $350 million in 6 years, resulting in the most successful tech IPO of 2010. Before Qlik, Rob ran marketing programs in the Mid-Atlantic Sales States District for Microsoft. Jordan Reynolds, who is Senior Manager at Calypso, is our second speaker today and a leading expert in advanced analytics and digital product innovation with management experience across ideation, strategic planning, solution design, and program execution. With success applying both to established and cutting-edge innovation capabilities, Jordan has a unique perspective on how companies can enhance their creative aptitude and maximize the return on innovation investments. The third presenter today is Michael Glessner, a director at Calypso who has extensive experience systematically commercializing products and technologies, developing strategy, and deploying enterprise technologies for life sciences, aerospace and defense, and manufacturing companies. Rob's areas of expertise include new product development, business and innovation strategy, large-scale organizational change leadership, and open innovation. Prior to Calypso, Michael led design and product development activities at Green Tweed & Company, a global manufacturer of high-performance materials and engineered components. Now for a few housekeeping items, starting with the features of the audience viewing console. The Enlarge Slides button will maximize the presentation slides to fill your entire screen. The Download Slides button allows you to download and print the slides if you prefer to follow along with a hard copy. Next, the Forward to a Friend button enables you to send an email that includes a registration link to this eCast so that friends and colleagues can also attend. Perhaps most importantly, the Ask a Question text box allows you to participate in the event by simply typing questions into the box and hitting Submit Question, the button below. You can submit questions at any time during the course of the presentation, and we encourage you to do so early and often while you review the material. We'll address as many of these questions as possible during the closing Q&A, and also if you have questions about the operation of the eCast itself, you can submit those and one of our technicians will be happy to assist you. One last note before we begin is that all Open Systems Media eCasts are copyrighted and may not be recorded without prior permission. So at this point, I'd like to hand it off to Rob Patterson of PTC. Rob, the floor is yours.
Thanks, Brandon. Good morning, good afternoon, everyone. Really excited to be here today. Again, my name is Rob Patterson. I'm part of PTC. I'm joined today by a couple of our great friends from our partner at Calypso. Calypso and PTC have been partners for several years, really working to bring IoT and bring value to IoT through things like using machine learning and artificial intelligence types of analytics to mine large sets of data coming from the IoT space. But what we're really talking about today is, how do you begin your journey, or really how do we define the IoT space, and how do you get started small and then begin to expand out? I think we see the market growing. We see what's being produced by IoT or industrial IoT growing as far as data sizes and those types of things. But how do you really take a fraction of that, prove value, and really start to grow it out inside of your organization? So we'll be talking through some of those things today. So we did get a good introduction from Brandon, but what I wanted to do right now was have Jordan and Michael introduce themselves to the audience, and we'll kick the content off right after that. So Jordan, Michael?
Sure, I'll just start. So I'm Jordan Reynolds. I'm a senior manager with Calypso, and Calypso is a management consulting firm that's focused exclusively on innovation and product development. I started with an academic background in artificial intelligence and computer science, and actually I'm a PTC alumni as well. So my very first job out of college was a solution architect at PTC, where I began to learn about things like product development and innovation. I eventually became more interested in really the business side of all the interesting technologies and in operating models that we were applying at PTC. And so I came to Calypso, where I can provide more of a management consulting skill set. And sure enough, PTC began a course of investments into IoT and artificial intelligence technology. So I really came full circle back to my academic background and was given the opportunity to advise on things like machine learning and predictive analytics and artificial intelligence and its application to the product lifecycle and to product development in general.
Let me
Excellent.
continue.
Michael.
Yep. Michael Glessner, Director. I've been with Calypso about 5 years now, and I lead our industrial high-tech industry practice team. As such, I draw upon a lot of my personal background. Degreed engineer, spent 30 years basically bouncing between industry and consulting, but I have had roles in operations, quality, engineering, R&D, at the individual contributor level, management level, and executive level. So drawing upon those, what I've found in my IoT-related work is I seem to get involved heavily in selling these concepts to executives and executive teams, kind of bridging that gap from the technologists to the business need itself. And then once sold, operationalizing that, all right? So the organizational change and basically fostering and promoting user adoption so that these changes fundamentally take hold. So definitely looking forward to the conversation today.
Yeah, absolutely. And again, I'm Rob Patterson. I'm VP of Product Marketing for the Technology Platforms Group at PTC. I think all you need to know, about me and where I sit in the world is I love IoT, I love analytics, and I think I'm in the right spot to talk today. And we had some really interesting conversation to go back and forth with my colleagues here. So a little bit of a different format today as far as how we're going to be doing things. We're not going to, PowerPoint you guys to death or any of those types of things. What we're really going to do is have a discussion. So me and myself, Michael, and Jordan are going to talk through a couple different points. We do have some slides to emphasize some things I think you'll all find pretty interesting throughout the presentation. But we're going to be talking about how do we define industrial IoT, what does the business opportunity look like, and specifically what does the business opportunity look like as it's tied to analytics. Some tips for you to get started. Calypso is really the expert on getting this stuff started within your organization, so they can provide some great tips from working with many different clients alongside PTC to help you get going. And then the importance of analytics. So why is analytics so important inside of an IoT solution? Why does it really add exponential value in terms of what can be provided through an IoT solution to an end user? So we're going to be covering a lot of great stuff today. So I'm going to kick this off. Michael, first question's for you. How do you define industrial IoT, and how is it poised to change the industrial world?
Okay, let's start at a very fundamental level. When you think of IoT, it's really a collection of a lot of physical devices, sensors, actuators, equipment, objects of all sorts that are that can be individually involved in some aspect of IoT or combined into a system or a system of systems. Right? So you have this collection of objects, and then number two, they're connected via the internet. All right, and through that connection, we then are able to, number three, enable them through the digital data that's being passed. All right, and the cloud-based technologies that are leveraged to really create some very new and interesting possibilities for businesses today. So with that as a very broad definition of the industrial IoT, how this is poised to change going forward, fundamentally this is changing nearly every aspect of industrial value creation that we are aware of at a very fundamental level. All right, challenges and changes, very real. It's a disruption, and what's fascinating to me is it's actually disrupting portions of the economy that have been very stable for decades. All right, are under some real pressure to consider differences in their ecosystems. Now, many of these differences are fundamentally focused around the concept of optimization. All right, and optimization in a real-time fashion is a game changer in many respects. It changes the work, it changes the way objects and systems interact with one another, and from a business standpoint, it's fundamentally changing business models in many corners of the world. So as the work changes, organizations have to change along with it to enable it and see it through effectively. So uncharted territory, kind of across the gambit, and very exciting as to where this is headed. So, Rob, let's send this back to you to kind of continue that discussion.
Yeah, and I think really when you look at this slide here, and this is something we talk about at PTC pretty regularly, it's, building on what you said, Michael, IoT is really impacting every facet of the business. And when you look at it at a macro level and how it's going to really impact not only just industrial, but look at consumer and look at kind of generalized IoT as well in areas like healthcare, retail, it's fundamentally poised to have an impact on us as a society along the lines of what the Industrial Revolution did and along the lines of what the PC revolution did back in the 70s, 80s, and 90s. And, when you look at how this is all going to impact a business and how it's going to operate on a daily basis, it's going to impact every single department and every single function, whether it's sales or marketing getting better customer intelligence back from a store level, or engineering understanding what's going on inside a production line so that they can better and more efficiently create or service their production lines to maximize yield output. So every aspect of the business and every output of the business is impacted by IoT. Now, the challenge with it becomes, there's many different aspects of IoT. You have your devices, your networks that can be made up of mobile networks or things just connected back to the internet through some type of different connection. You have then application development, all leading back to fixed applications or fixed solutions. Now, there's inherent challenges with all of this. There's many different tools on the market today as far as, and I'm not going to go into the sales pitch here, it's just kind of what we see overall in the market from a PTC perspective is that there are a lot of solutions out there that provide some type of functionality at each of the stack, whether it's connectivity, whether it's device cloud, whether it's some type of application development tools or enablement tools where you can build user interfaces or build some type of database on the back end to house all the information coming off of connected devices. And then maybe there's a UX or UI design tool to publish out solutions. The challenge becomes, how do you get everything to work together? You're talking about, Michael, you said, potentially thousands or millions or billions of different data streams and sensors that need to be looked at and evaluated. And, not having a fully connected stack to develop on does things like, or it starts to bring up questions around complex programming and being able to, or how much back-end plumbing is going to need to be done from a programming perspective to get everything out at the edge, talking back to full solutions being deployed out to end users. So, the really getting the true value out of IoT solution development is a challenge because you have a lot of these tools. And really the true way to facilitate and get around this is through the use of a platform, something that provides edge software, your device cloud, being able to use either a device cloud or interoperate potentially with other cloud vendors or cloud stacks that are being utilized in your organization, having embedded application enablement tools that lead back to a centralized repository of data to build applications and build solutions off of which analytics are embedded into, and we'll talk about that in just a few minutes here, provides a huge amount of value in deploying these solutions out into market. So I think that when you look at either using fragmented tools to develop solutions or having the choice to look at a fully integrated platform from top to bottom, the fully integrated platform is going to allow you to develop faster, develop smarter, more robust applications, and really develop things that are more secure, that can scale and build over the course of time as your IoT or industrial IoT infrastructure eventually builds out. So next question here. What opportunities does IoT present to the industrial business, both internally and externally? Guys, you want to chime in on that?
Yeah, absolutely. So, Rob, you made a great point that IoT is impacting just about every function in every department of organizations that adopt it. It's also impacting just about every phase of the product lifecycle. So if you start with manufacturing, for example, industrial manufacturing organizations are leveraging smart connected capabilities in their production facilities and their assembly lines to better understand the underlying root causes of high quality and poor quality and be able to intelligently monitor in real time all the operations of their manufacturing procedures and prescribe different courses of actions that are going to produce higher quality products, better yields, lower cost of poor quality, and ultimately just a better output from manufacturing. So it really starts even before it gets into the customer's hands. Now, when it gets into the customer's hands, this is where we really see the classic and well understood application of IoT, and that is enabling a smart connected product that understands the way that the customers are using it, understands the way that the product is operating, and being able to gain insights into when the product is going to fail and under what conditions it operates optimally. And you can use this for a variety of different purposes, both in terms of just generating product advantage, adding features that are better than the features that your competitors are offering, understanding the way that your customers are using it, and then being able to predict when failures are going to happen to respond preemptively. And now you can imagine that there's even external value to all of this information and data that you're collecting from this customer product experience. Any information regarding the way that customers use products, which product features they prefer, how the products operate within market environments where they're being integrated into other capabilities. All this data is valuable. And if you even look at it just from a data perspective, it's really transforming the way that IT organizations work. So IT has traditionally been sort of a service organization that operates internally in support of the business. IT organizations are now evolving towards P&L owning business units that own data and look for ways to monetize that data into new products and services. Okay. Now, one of the most interesting things is that leveraging this data also brings you back to the first stage of the product lifecycle in that it informs the ideation, conceptualization, and engineering process to begin with, right? So if you are looking for new ways to introduce new products or think about ways to improve existing products, understanding the reasons that products fail and the ways that customers interact with your products, this is an obvious advantage to improving their next revision of your product and ensuring your ability to generate more and more products in your portfolio as time goes forward. Okay.
Yeah, Jordan, and to get back to your point, I mean, when you look at the momentum that's coming behind or coming through IoT, it's really growing pretty substantially. The number of connected devices back in 2014, were around 10 billion. And when you look at what's being talked about in 2020, we're talking over 50 billion actual devices that are going to be connected. Now, what these connected devices are actually going to show here is, we're going to have those 50 billion devices, but we're also going to have more data that's created. So when more data is created, back to your point, there's more value that's hidden within those data sets that needs to ultimately be mined and shown, but not only just mined and shown, but how do you develop things like predictive intelligence, and how do you develop things like recommendations and simulations to provide all users of an IoT solution greater insight into what they should do to do things like avoid downtime or understand when service needs to be done on a certain piece of equipment. But not only just giving them predictive intelligence or simulative intelligence, but giving it to them in a context that they understand. Because they don't, nothing against assembly line workers or those types of things, but I don't think they would understand a rock curve and how to really interpret different things coming off of a simulation matrix where they need to make a decision on. But if you gave them a list of top 10 reasons why a piece of machinery will fail, they'll be able to understand that and interpret it. So how do you do that, and how do you mine that? Well, when you look at what's currently out there in the market today as far as what's available from a reporting or even a business intelligence and even a predictive intelligence solution standpoint, the challenges that are with them when it comes to IoT. Now, the one thing I want to be clear about is that operational reporting, data exploration, data discovery tools, and statistical and advanced analytical tools all have their place in an organization. They all do some type of analytical work, and they will continue to do some type of analytical work. But when it comes to being built for IoT, when you're talking about potentially billions of points of information that, again, need to be investigated, correlated, mined for value, and presented to a user in a way that they can understand, these tools really fall short. And they fall short for a couple of reasons. When you're talking about something like operational reporting tools are usually static reports that are delivered to some type of business decision maker or technical decision maker that don't have much flexibility. They have predefined variables and predefined values that are pre-aggregated and delivered inside of that report. Now, those reports are valuable at some level, but when it comes to making things like real-time decisions or proactive decisions on data streams coming off of IoT, data from yesterday isn't going to work. You need to know that information now. Shifting to something like a data discovery tool, when you're talking about, querying data in real time and getting answers back, that's fantastic to be able to do that. The challenge with it is when you're talking about such a large volume and variety of data, when you're using a data discovery tool, relies solely on the end user or the user of that application to investigate the data, to extract the value of the data set. It doesn't show the user what's important inside of the data set. And then finally, when you're talking about statistical or advanced analytical tools, these are typically tools used by very small sets of individuals inside the organization. They usually have very limited data set sizes and very limited reach in terms of what they can be integrated to and implemented to deliver that type of intelligence to an end user solution. So when we talk about how do we shift fundamentally to a way that IoT data can be mined and shown value, there are ways to do this, and one of the ways is through the use of very sophisticated machine learning and very sophisticated artificial intelligence to mine data, look at data in real time through data streams, be able to detect things like patterns and anomalies within data streams to ultimately deliver real-time actionable intelligence. I know that's kind of a buzzword, but really deliver real-time intelligence to operators so that they know what's going on inside their IoT ecosystem and don't have to investigate to figure out what's going on inside the IoT ecosystem. So we'll talk a little bit later about, in a couple minutes here, about different ways to do this. But, I wanted to go back to you guys real quick with a question here. How quickly is the industry adopting IoT, and is there a clear maturity curve of work? I mean, I have my opinions on this, but I'd like to get your opinions. You guys are the ones on the front lines really fighting these battles and working with customers to get solutions up and running. So I'd love to hear your take on this.
So, Rob, this is Michael. Let me take a stab at that one. First of all, I want to underline what you said about billions of points of data. All right, billions of points now possible and out there and active, being captured, and folks really looking at that from their business perspective, knowing that there's value in that data. If you think of it today, data is the new oil. All right, there's tremendous value there, and people are now trying to mine and harness that effectively. So from a standpoint of how quickly this is happening, it's a tidal wave of activity, but it's very interesting. I'd characterize it as cautious activity, and in that caution, it's a lot of experimentation. So you also, Rob, you were talking about these small pockets of folks working with some limited tools in various aspects, some more sophisticated than others, but they're testing ideas and trying things, looking for use cases that really do in fact make sense. Now in that, the point about the maturity curve, there is absolutely a curve with participants here. Some innovators, early adopters have made a lot of progress, but I see a real chunk of fast followers that are trying to watch the press, understand what's happening, and react to what they're learning internally. So a tremendous amount of learning going on right now. And I'd say that from a use case standpoint, this is probably the most critical thing, identifying the use cases of most value to an organization. So those insights that Rob was talking about, all right, from the data, you can flip those into predictive maintenance type use cases or process or outcome optimization type use cases. And we see a tremendous amount of activity in industrial global players around those subjects, and I think more to follow. So I think insights in time will become the differentiator, the key differentiator in the near term, and companies that can get their hands around that quickest will probably be best positioned. So let's take this a little further and drill further into the important parts of the solution. Jordan, do you want to comment on this?
Yeah, absolutely. So the question of what types of analytics can be deployed is an important one. And if we think back to sort of our history within the business world of applying analytical techniques, we think of things like business intelligence. And what business intelligence is really a form of what is called descriptive analytics. It's generally an analytical technique that's used to describe a current situation that is going on. And if you can better understand that current situation, human beings can make predictions about the root causes, understand what's going to happen in the future, and then take action accordingly. And business intelligence is important, but back to the concept of literally billions of different data points suddenly being democratized and available to mine insights from, this is unleashing an entire new arena of new analytical techniques that can do other things programmatically. And so we start to think about things like diagnostic analytics and predictive analytics and even prescriptive analytics as well. So let's talk about just the diagnostics for a second. It's even more valuable when you understand that a situation is going on. Let's say that situation is a product failure. It's some sort of failure mode from down. You understand that it's broken down, but what if you can now understand the statistically likely causes of that type of failure based on those billions of data points that describe the situation? Okay, so now you're even deeper into the process of actually solving it. And taking it a step further from there, what if you're able to understand all the various environmental factors that are going on when a tractor or automobile is operating effectively, but then notice leading indicators that are historically associated with failure? And that'll give you the ability to actually predict when that failure is going to happen preemptively so that you can take some sort of planning effort to address it before it actually happens. Okay, and then finally, probably the most advanced and aspirational form of analytics is prescriptive, where you're actually looking at a circumstance and prescribing a course of action with minimal or even no human intervention necessary. So we talk about how new analytical techniques and also just increasing volumes and varieties and velocities of data are making this possible. The reason why these things weren't possible in the past is because all of these things require explicit programming under normal circumstances. So with artificial intelligence and machine learning capabilities, you have models that are capable of learning what to do and what to think and how to interpret something on their own without having to employ a team of programmers to explicitly code in the rules and the dynamics into some sort of application. Right? So the availability of this data has really unleashed the power of these analytical algorithms to be able to learn circumstances and understand relationships and identify patterns on their own. And this is as applicable in the business world as it was in academia where these algorithms were developed. Okay.
Yeah, Jordan, and just to take that a step further, let's take a step back here real quick. There we go. So to take a step, to take this a little bit further, where do you start? There's so many different types of analytical approaches, techniques, things you can do with data when we're talking about those billions of points of information. Where do you start as an organization? So I think it starts towards the left-hand side of the screen here, and it's really about how do you look at data streams in real time, and how do you apply, things, and how do you apply different analytical techniques out at the edge of a network versus having to look at data and bring data all the way back to a data center. So being able to use the AI and machine learning technology, as you just said, to run things like pattern and anomaly detection and look at real-time data streams for those things is hugely powerful and pretty simple to do, at least within our platform, from a analytical standpoint, so that solutions that contain this functionality can really alert end users to when things are happening in real time. So there isn't that self-discovery or aspect of unleashing those billions of points of information to find the value. You're being told in real time what's actually important inside the data set or important inside the infrastructure at that particular moment. Now, the next step to that is how do you look at predictive capabilities and simulative capabilities and correlating that back to things like efficiency. So looking at, how a certain part might impact efficiency on a piece of industrial equipment is hugely powerful for things like predictive maintenance and, predictive service on production lines and those types of pieces of equipment. But I think that, that's the next evolution is how do you take the intelligence that you're seeing out at the edge or out at, from an anomaly and pattern detection, and then grow into how do we run predictive analytics and simulative analytics using machine learning and AI technology on that particular set of data. Now, I don't have it on this slide, but I do agree with you. I think the pinnacle of all of this is when you get into prescriptive analytics. And prescriptive analytics, a lot of organizations have a little bit of difficulty wrapping their head around how to use prescriptive analytics, but I think that once you get up this maturity curve of using pattern and anomaly detection for real-time analytics, predictive and simulative analytics for things like efficiency correlation and different proactive types of measures and analytical possibilities inside of your solution, then you get to talking, okay, what do I need to do to maximize an opportunity, minimize a risk, or eliminate downtime on my production line, or those types of things inside the organization. And that's all done through prescriptive analytics. So, guys, I really think that when you look at analytics and its use inside of organizations and inside of solutions for either IoT, industrial IoT, even consumer IoT, analytics is the backbone or foundation, and it is the killer feature or killer app inside of those solutions. I think without using the techniques that Jordan and myself and Michael talked about today around machine learning and artificial intelligence, you're potentially missing out on a huge gold mine of information that can help you make money, save money, reduce risk inside of the organization. So everybody from medical device companies, whether it's looking at equipment availability or two other examples on this slide, a petroleum company with production downtime, and then a production company looking at high-tech discrete manufacturing, looking at temperatures within an assembly line and how it impacts manufacturing. All of these things, analytics is the backbone to all of these solutions and providing this intelligence. So I think what's important to take away from this portion of the conversation is that without having analytics embedded inside of a IoT solution, you're missing a huge piece of value that potentially that solution can deliver to end users. And I would argue that a solution without analytics embedded in it is a next to empty solution. It needs analytics in order for it to really deliver the value and deliver the promise of what an IoT solution should deliver an end user. So guys, let's wrap up the conversation with this last question, then we'll turn it over to the audience to ask us some questions. So how do you get started? You guys are experts on getting companies started. I'd love to hear how you get your clients started and really what types of analytics are needed for an effective IoT strategy. I talked about a couple of them. Jordan, I'd love to get your expertise on what you think are some additional techniques or strategies for applying analytics in an IoT solution.
Yeah, getting started is probably the question that we hear most from our clients or any prospective clients that we're working with on the topic of machine learning and analytics. And one of the things that we consistently observe is that there is rapid advancement in the sophistication of the algorithms that are out there, and there's rapid advancement in the volumes of data that are capable of being managed. And all of these technological capabilities are growing at just this exponential rate. but the ability for large-scale organizations to adopt these technologies and really institutionalize new business capabilities internally is somewhat lagging, right? I mean, all of these things can come off appearing as lofty, sort of aspirational goals that are ambiguous and hard to understand and even kind of intimidating. And so, in the face of all that, rather than recommending a large-scale transformational investment into changing your business to adopt artificial intelligence and machine learning, we actually recommend starting small and taking sort of a business case and proof of value oriented approach. And so generally 3 steps when we start off advising our clients on how to begin to adopt this. And the first step is what we call the art of the possible. And this is really starting by understanding what the real business impact of these capabilities would be. So before you even get into investing in the right algorithms, hiring data scientists, and understanding how to put the technology into place, what are you fundamentally trying to achieve for the business? What are some of the possibilities? And sort of going through a process to identify, prioritize, and eventually funnel and reduce all the ideas into a number of possibilities that you can gain support for, that incentivize people in the organization that need to provide capital funding for it, and that really create enthusiasm and passion from your colleagues. And so after we move from the art of the possible process, generally we go into sort of a formal business value hypothesis formation. And so this is like a really deductive business case that demonstrates if we apply these capabilities to X, we can accomplish Y for the business. And that Y can be some sort of financial outcome, like reducing your cost of goods sold or producing incremental revenue, or it can be something more strategic and qualitative, like being able to attract a growing customer segment like millennials, for example. Okay, and so once you've identified these business value hypotheses, now it's time to test those hypotheses with a strategic experiment. So this is really the scientific method being carried out to bring these capabilities to your organization. And so when we talk about strategic experiments, generally what we do is, in the context of that business value hypothesis, we'll put together a working proof of concept that takes actual data sets from actual products that our clients manufacture, applies these working algorithms, whether it's neural networks or ensemble models or gradient boosted trees or whatever the right combination of models is, and demonstrates results in pursuit of that business model hypothesis. Okay, so now if you've done that, the question is no longer what technology do we need. The question is now, how can we get this into place faster so that we can actually realize these financial results sooner? And really the business case writes itself from there, right? If you can actually demonstrate this in working order, the ambiguity is eliminated. And the discomfort with concepts like artificial intelligence and machine learning is somewhat tempered. This becomes a real opportunity that people see around them, and they begin to develop parallel ideas on top of what you've come up with. And this sort of organizational change management process, which many times hinders projects from becoming a reality, begins to move forward smoothly. Okay.
Great. Michael, anything to add to that?
No, I think that was very complete. The only other thought that really comes to mind is how you solicit the support of the executives as you go through this process. So as Jordan was explaining the art of the possible, in many instances, we're really trying to win over executives through that process and have them anxious and really anticipating the outcomes of the study. All right, so you want to bring them along with you and not surprise them with unusual recommendations at the end.
Yeah, and the only thing that I would add is, this goes back many years, and one of the CIO that I used to work with, I guess it was about 10 years ago right now, said to me, the the true challenge of analytics isn't the technology, because there's a lot of technologies out there and approaches, and Jordan, you went through a lot of them to mine data and deliver intelligence. It's really, in getting started, you really have to fundamentally ask, what does the business want to see from the data? And I don't think that changes much in terms of IoT. You need to understand from your IoT infrastructure what's going to have the largest impact to help you save money, make money, reduce risk inside your organization. And really aligning your analytics strategy to that is going to help you really develop more insightful solutions and more valuable solutions for your organization to use or embed inside of your technologies. So, with that, we're going to open it up for Q&A. Brandon, can I hand it back over to you? I believe you're going to be facilitating. We're looking forward to answering some questions from the audience.
Great. Thanks, Rob. That's some really interesting stuff there, and a really important part of the IoT going forward, talking about machine learning capabilities. And as Rob mentioned, that brings us into the Q&A portion. So submit your questions. Keep them coming. We'll get to as many of them as we can in the time we have remaining. A question here, and I'll pose this first to Rob, but then open it up to the other two speakers. Is there a need now to have a data scientist on staff at any company that is purporting to be an IoT company?
I would say yes, absolutely. There's a definite need, whether or not that person's easy to find. Data scientist is like a unicorn. They're very, very difficult to find. But yes, I think there is value. The one thing that I want to be clear about, and Jordan, I don't know if you agree with me or disagree with me on this, but AI and machine learning technologies are not replacements for data scientists. They are tools to help data scientists better do their job. There's always a need for a data scientist to understand, especially when you're talking about predictive analytics and simulations and predictive scoring, the whole aspect of, how efficient a model is in producing the scores for that particular output is something that needs to be understood by a data scientist and translated and communicated out to the business. Because you don't want false predictions, false positives, false negatives on a prediction that's being made. So I think there's definitely a need for a data scientist in the organization, not only for IoT, but just in general inside of organizations. Jordan, do you agree with that?
Yep. A data scientist, somebody with an aptitude for data mining and building and testing models and understanding how they scale is absolutely necessary. I would say, though, that it's not sufficient, and I'd say that one of the challenges that we see is that organizations will only hire data science professionals and then expect that their enterprise transformation will just sort of take effect because we have data scientists that understand machine learning, and that's really all we need. I think equally important to the data scientists are people that can really connect the dots between the capabilities of the data science work and then the actual business and customer needs that are going to drive financial value for the organization. And so that could be somebody that is product or business focused or marketing focused, but really having a cross-functional team that incorporates a data scientist is the recipe for success.
This is Michael. I could not agree more. That linkage is really critical. Understanding problems worth solving from a business perspective and pointing those data science resources in the proper direction is critical if you want a very productive and functional activity.
Great. Yeah, and with just one last thing, there's another question related to this. Having so many parameters and just the flood of data that's going to be coming in, the more resources you can have and having the expertise able to, see unforeseen data sets or trends that are coming through is going to be really important as we move forward with the IoT. Here's another question, and I think this one may be more appropriately pointed towards Jordan. Are there any machine learning tools that you would recommend out there right now?
Yeah, so we developed a relationship with PTC as an objective advisor of technology and business solutions that are out there, really because the ThingWorx analytics platform had one sort of special ingredient, and that is the ability to introspect data sets and sort of prescribe the appropriate model, without having to have a really robust analysis process before you do that, and really be able to showcase the output and the results much faster, right? So if you think about, where we're really comparatively advantaged today, sort of back to my point about how the adoption curve is still somewhat slow, if we can get from data to insights faster, that can be even more valuable than, the robustness and the completeness of the insights themselves. And so, from the standpoint of tools out there, we prefer to use the ThingWorx analytics package for proof of concept oriented projects where you can very quickly derive insights out of the data, and then also in cases where you have smart connected products that are the source of the data rather than just your enterprise systems and social media data and things like and marketing information, which has been the traditional source of data for machine learning. So the ability to kind of pipe in the data that's already being produced off of the ThingWorx connectivity platform from smart connected products directly into the ThingWorx analytics package really speeds the process by which you can showcase and demonstrate value from the capability. There's a number of other tools out there that I prefer sort of in combination. The R package, just the letter R, is really great as just sort of a standalone data science toolkit. It's also sort of connected in with a community of other data science professionals and then data sets that you can use as examples. And a lot of times when I'm starting off, even not even thinking about deploying it to production yet and using sort of a enterprise stable tool like ThingWorx Analytics, start off with R just to sort of build and test models and get to the right point of maturity, and then think about how to deploy it to production. And there's a few others out there as well, but that gives a basic base covering.
Excellent. Here's a little bit of a follow-on to that, and you may have answered it somewhat, but just to be specific. So in terms of disciplines that are behind PTC and Calypso that you would prescribe for analytics in a machine learning sense, there's hidden Markov models out there, natural language processing, deep neural networking. What would you suggest is deployed, or is it case-specific?
Yeah, it's interesting looking out into academia, into other large technology-oriented organizations like Google and Amazon, and looking at the types of algorithms that are being developed and just the speed at which they're evolving. There are people out there that are even competing on platforms like Kaggle to design the best machine learning model for a specific purpose, and just sort of that force of competition is driving these things to move forward really quickly. The things that really stand out today as the most valuable algorithms and statistical techniques out there, obviously the deep learning capabilities of neural networks and, neural networks that can be applied to sort of highly organic problems where there's not a very obvious discrete or binary yes or no choice. And then even getting into things like image recognition, you get into things like convolutional neural networks, which are even more complex. And then there's also things that are more based on really complex conditional logic, like decision trees and ensemble models and gradient boosted trees. And then sometimes, simplicity is the best thing. So sometimes something like linear or logistic regression, basically the techniques that you learned in college calculus can solve the problems most effectively because they provide the most simplistic representation of a model. So, really the important thing is understanding the context behind the data and then the problem that you're trying to solve, and understand how to pick the right algorithm and then how to configure the algorithm appropriately to solve that problem. And then, beyond that, testing your actual hypothesis, testing your model, and seeing how well it performs by, having a quantitative measurement to see how often it's right and how often it's not right. Those are really important. So a lot of times we get questions like, what is the best algorithm out there? Well, unfortunately, there's no simple answer to that. There are some competing models out there like neural networks and ensemble models and gradient boosting, but it really comes down to the type of data and the type of problem that you're trying to solve.
Great. And depending, any of these can be integrated into PTC depending on the end goal.
Yeah, so PTC comes with ThingWorx Analytics platform specifically comes with a really comprehensive suite of the algorithms, including the ones that I've mentioned, and then the ability to consume other algorithms through publicly accessible APIs as well if you want to do something sort of outside the scope of traditional algorithms.
Great.
This is Michael. Let me just jump in with one other point. It's important to match the appropriate technology to the challenges Jordan has described. The other piece of this, though, is once you've done the work and you have the results, you've got to frame it back to an executive organization that may not understand the nuances. And you've got to be very careful with how you message that and how you package that to be successful. Because fundamentally, to some people, the answer leaps off the page and they understand it. Others look at it and their eyeballs roll up into the back of their heads, and you really need to walk them through what it's saying and why this is such a benefit. So the simplicity of that communication and the elegance of that communication is also quite important.
Fantastic. Here's one for Rob. There's an agricultural tech and financial analyst company out there, and they cover, as you would expect, large geographic areas. The question here is, what is the right type of connectivity to deploy to get information from sensor back to a back-end cloud platform? We're talking cellular, LPWAN, RF, Wi-Fi. Is there something else?
Well, yeah, it's going to depend on the infrastructure and what's available from a connectivity standpoint on a specific farm or where those actual devices are being housed. I mean, it could be through cellular networks. They could have some type of cellular capability on each of the individual sensors, or there could be towers within the network that are actually setting up a wireless network for the sensors to feed information back to the overall technology. I think it's more of a hardware architecture for that individual use case in terms of what the appropriate protocol would be in order for getting that information back, or the appropriate path for getting that information back to the device cloud. But it could vary. That's kind of a wide question that would need more conversation into it in order to figure that out.
But principally, device cloud's agnostic in terms of connectivity, correct?
Correct, yeah. Most are. And our platform at PTC, we have our own device cloud that we can interoperate with or operate with, but then we can also, for an organization's using AWS device cloud or Azure or SAP HANA, we have the ability to bolt directly into those and use those as the cloud storage for the infrastructure, but still use the rest of the platform capabilities, including the analytics stuff we're talking about today, with those other technologies.
Great. And to the answer to the question, a couple just off the top, LoRa, NB-IoT, or a couple that you might want to investigate for that type of application. Next question here, and actually I'll pose this one to Michael and then let Jordan and Rob pencil in anything that's remaining. But if you're trying to gain traction for an analytics initiative within your organization, Michael, what is the best way to start? You've talked about dealing with executives and explaining these solutions to them. What's the first step in getting the ball rolling?
That's a great question. Really what you need to fundamentally understand is the mindset and perspective of the executives from their business model perspective. So you really need to understand from their perspective what are their current challenges, what's keeping them up at night, and how some of these technologies and disruptive possibilities may impact some of their concerns. That would be first. Second would be, if there's areas that they're already doing well, how might you be able to take that even to another level that they haven't even thought about with a new business model or business model enhancements of some form that could really change the game with the way they compete. Once you understand that, you can then go back and what Jordan was describing in terms of the very set, explore the art of the possible into business value hypotheses, into real specific proof of values really comes to mind and light. And now you've got the full context, if you will, for making sure that it's really valuable and appropriate for that particular business, and the executives see value and will likely fund it.
Great. Rob, Jordan, anything to add to that?
Yeah, I would just add, going back to a previous statement I made, and I absolutely agree with everything you said, Michael, but it's clearly you need to understand your business, first of all, how it's going to go back to your overall business strategy, but then understanding what you want to see out of the data and how what you want to see is going to impact your business. Because I think understanding the business impact before actually executing the technical aspects of analytics is far more important and takes far more time than actually implementing the actual technologies.
Nope, that's well said.
Great. So here's a question now about companies' actual use cases, because everybody loves use cases. Who's succeeded deploying IoT, sensors, machine learning in the field and seen benefits from it? I mean, still, some of this stuff is to the greater public kind of science fiction. Are there any real use cases out there?
Yeah, I'll give one. So I won't. I'm not going to get into specifics in terms of the actual organization, but so we are working with a number of clients in the agricultural space, and what you might describe as precision agriculture or smart agriculture is a really large and growing landscape of investment right now. And so some of the problems that we are seeing them solve with the actual capabilities that we're describing are things related to being able to understand and predict when their products are going to fail, or even understanding like the intensity of the usage and the type of usage of their products, and then sort of like taking that a step further and being able to use that as a pseudo-economic indicator for things like how many warranty claims they expect to get that month, or how many part replacement sales they expect to get. And then suddenly they can stock their inventories more effectively and write their warranty terms more effectively. They can manage sales forecasts more effectively if they understand the likelihood that a farmer is going to need a new piece of equipment, right? And then even more important than that is they're collecting these data sets that can be monetized externally to third parties that are interested in all this agronomic information that helps them predict what crop yields are going to be, and other aspects of the supply chain prepare themselves for the number of crops and the types of crops they expect to receive. And this propagates outwards in this sort of value chain reaction all the way to distributor networks and grocery stores and restaurants, et cetera. So, the value opportunities are not just unique to the companies that are investing in the tools. It actually creates opportunities through this sort of supply chain working outwards in kind of concentric circles from the company that's doing it. Data has this ability to create value for everything sort of in the environment around the company that's using it, not just the company itself. So that's one example from smart agriculture. Rob, I don't know if you have any others that you wanted to mention.
Yeah, I mean, none specifically, but I think that there's a certain focus area for analytics that's coming up a lot in industrial IoT, and that's around predictive maintenance and things like avoiding downtime and those types. And we have many, many different partners and clients either developing solutions or developing products that have some type of predictive maintenance capabilities built using ThingWorx analytics. So I think that when you look at, IoT and industrial IoT, service is really one of those kind of highlights of industrial IoT, and predictive maintenance seems to be at the top of everybody's list. So we're seeing a lot of use of our technology for that.
Yeah, I just add one more point to that to sort of make sure everybody understands that this is totally applicable outside agriculture as well. So in the industrial manufacturing space specifically, you have a lot of complex machines with moving parts that are operating and running in various modes, et cetera. And anything that's moving and that is subject, to the basic laws of physics tends to fail in consistent ways. And because of that consistency, there are patterns and relationships that can be mined out of large data sets. Now, this is very different than predicting the stock market, which is really driven from psychology and consumer behavior that's not always consistent. But when you're talking about physical machinery, you really have these amazing opportunities to understand the root causes of things and then to be able to predict what's going to happen in the future, assuming that your data sets are sufficiently large and robust. So really any industrial application, whether it's in oil and gas or automotive or aerospace and defense or agriculture, I mean, you name it. When you're talking about physical devices that are operating in different modes and you have the data, you can start to identify patterns, make predictions, and then prescribe courses of action.
Yeah, just to close that out, Jordan, I think that you hit on a key point, which is in order to use machine learning and AI for predictive analytics, you have to have an occurrence appear within the data set. It's not a crystal ball. It can't just pull things out of thin air. It's got to learn from something like a failure or part failure. It's got to learn from historical part failures what that looks like in order to be able to generate it for the future.
Great. Thanks, guys. Unfortunately, that brings us to the end of our time. And those of you who had questions we didn't get to, we'll be sure to have appropriate representatives follow up with you. I want to thank Jordan Reynolds, Michael Glessner, and Rob Patterson all for their great insight there on analytics in the IoT. And we at Open Systems Media, Calypso, and PTC would like to thank you, the audience, for attending today and contributing some great questions. This eCast will be posted online at the URL shown on your screen within 24 hours, and an audio-only podcast will be made available there as well. You can do a web search with the keywords embedded space e-cast and find all of Open Systems Media's eCast available for download there as MP3s. Thanks again for attending, and have a great day.